Hi, today we're going to be talking about ocean water basics and how we're going to talk about like salt water content, how the ocean water became salty in the first place, and then what would happen to the water at different depths as you go farther down into the water. So first let's talk about a very important vocab term, salinity. Salinity is simply the amount of dissolved salt that is in the water. And the salt that you find in the ocean, it's just NaCl, sodium chloride, the same stuff that you use on your to salt your food, the same exact stuff that we talked about. Remember, thinking back to minerals, remember we talked about halite, and that's the natural mineral that grows, that's salt, NaCl, same stuff. This map over here just shows you that the saltwater content is not just sodium chloride, it is most of it, but there are other important minerals that belong in the ocean water too. Now, usually if you are tasting salt water, you're not just getting sodium chloride, you're getting other stuff too, but it's perfectly fine. Not harmful. Okay, so how did it get salty? Well, it all starts with rivers and streams. So rivers and streams are flowing down and eroding, cutting that land away over time and carrying all that sediment with that precious minerals with it to the oceans. And once it gets to the oceans or to the seas, they really stop flowing. Yes, oceans have currents, but for the most part they're fairly still bodies of water. They can move around, but they're not going from one source to another and emptying out elsewhere. They're not refreshing itself. So it does just tend to accumulate over time. So now we've got this accumulation of minerals, but let's not forget we also have a very important water cycle step happening, evaporation. Over time, the ocean water, because our planet is so much water, the ocean evaporates a ton into our atmosphere, but it's a water cycle step. So water cannot evaporate with all of those minerals in it. It is just the water that leaves the water. It is just the water that evaporates out. The minerals and the salts get left behind. They stay in the ocean or in the seas. So over time, the ocean's water just becomes much more concentrated in minerals, making it saltier and saltier. And since our oceans are millions of years old, you can, kind of tell where that came from. Whereas rivers and streams are continually flowing, you have a recharge, refresh source coming from it, so it doesn't have a chance to actually accumulate minerals and become that super saturated with the salt. There you have it. That's how the oceans are salty. Also, let's talk about what salt does to the water temperature. So fresh water freezes at 0 degrees Celsius. That you should know. But ocean water does not do the same thing. Ocean water freezes at negative 1.9 degrees Celsius. So it's much, much lower. Keep in mind when water freezes, the salt is also left behind. So think of the ice caps. The ice caps that have formed up in the pole regions, when they are melting, which we've been hearing a lot about in the news, the meltwater that's going back into the oceans is a freshwater source. So that can be almost kind of diluting the ocean of that saltiness that it's used to. And that can be a bad thing. So really just keep in mind that salt acts as like an antifreeze. Same thing of why we use salt to de-ice our roads, to get the ice off, for the snow melt, for it to be safe. Same reason. Salt will make it harder for it to be in its frozen state. So let's talk about where on this planet you'd be able to find lower amounts of salinity versus higher amounts of salinity. And I'm talking about still just ocean water here. So for low salinity, you would expect to have areas where they are like in the Gulf areas where rivers are emptying out into the ocean. Think of those deltas that we talked about around the wetland areas. They're going to be less salty. So in areas where you have the large, like for example, consider the Mississippi River be flowing about right here and emptying out here. Notice that little bit of blue section on the map. Right there would be where it's emptying out. And so that would be slightly less salty place for you to go. Also in areas where you have a large amount of ice or snow melt occurring, so that would be higher up in the polar regions like around Alaska and stuff like that. And then also just simply around the surface of the water, because salt is more dense than fresh water. So salt water will sink. It's heavier. So the really high in salt content, the higher salinity the water, the heavier it is, so it sinks down to the bottom. So sometimes in some pretty still parts of the ocean, you'll find a very shallow surface zone where it's going to be slightly less salty. But they're pretty hard to find. Okay, let's talk about where you may not want to swim unless if you want to be in really super salty waters, which salt just helps make you float better. So that'd be helpful. So really you just need to go to the really shallow, warm waters. So around the Caribbean, the great places for you to go on your beach vacations. So on this map again, look, you have the Gulf of Mexico around on basically both sides of the Florida Panhandle. If you've gone to the Caribbean, Jamaica, all those areas have really super salty waters because it's so shallow, but it's so hot that the evaporation rate is much more accelerated than in other locations. Also, again, not quite as common, but around in the poles where water has frozen, because remember I said water can't freeze with the salt, so the salt gets left behind. So the fresh ice oftentimes is covering over a super salty water underneath it. So this map, it doesn't show it too well. You can see in some regions where you have higher, the red zones here is where it's more salty around the poles. But if you were to go underneath the ice, you'd see a really salty part. And then again, remember that the ocean's floor, the saltier the water, the more dense it is, so it sinks down. And then we'll get more to that when we talk about the deep ocean currents in a couple of days. So as you dive down deep into the ocean, you're going to pass through 3 different zones if you're going all the way down to the bottom of the ocean, which I would not advise. You're not going to get very far. So the first zone that you would be in, so wherever you swim, if you have swam in the ocean, you have swam in the surface zone. This is the warmest of all of the zones. It spans, if you go sometimes 100 to even 500 meters below the surface, you are in the surface zone. And you're going to have very little pressure. It's easier for you to survive. The crushing weight of the water is not pushing that hard on you because you're still so near the surface. The second zone down, you'd be in the transition zone. So the transition zone is going to be cooler in temperature because the sunlight can't get that far down into the water. So you've lost that warm sunlight. And you're usually going to be around 1,000 meters below the surface on average. That's about to the point of where it stops. So at the bottom of the surface zone to 1,000 meters below is the transition zone. And you are definitely going to be experiencing a lot more water pressure. Think of if you've ever swam down to the bottom of the deep end of a swimming pool. The weight of that water is crushing you. And that's exactly what happens in the ocean. The farther down you get, the more pressure that will be squeezing on your body and making your journey more hazardous. If you keep going, you're going to be getting into the deep zone, and that's simply from the transition zone's boundary all the way down to the bottom of the floor. So this is by far the biggest zone. It is the coldest zone and the one that you're going to experience the most pressure. And so last, we're going to have kind of more of a review. You will remember we talked about this, I hope. How do we know the depth of the ocean? So now we usually use satellites or radars to help scan our ocean floors of a more global map, although we still use the same method that we used to use just before. Like the only thing we used to use was sonar. We still use sonar, but not as much. Sonar, if you remember, is the ship sending down a sound pulse to the bottom of the ocean floor, and they wait and see how long it takes for that signal to come back up to the boat. So if it's a really long period of time before that pulse comes back to the boat, then the deeper the floor is at that point. So you could imagine this was not a very effective or efficient way of mapping the entire ocean floor. It took an incredibly long period of time, which is not good because, as we just learned, the ocean floor is constantly moving. You have new crust and old crust being destroyed, canyons and mountains being created. So by the time they finally mapped the ocean floor by just using sonar, part of it had already changed. Also, lots of errors. You can imagine giant pools of whales or fish swimming underneath would cause errors in the data. And such, and just malfunctions of the equipment. So we still use sonar, especially when we're searching for like ships that have sunk or anything like that. But for a large global scale of the ocean floor mapping, we use satellites now. So that is all you need to know about the ocean water.